Hello guys, my name is Siddharth Gavas and welcome to my channel Learn with Tech Bro, where I'll be talking about software engineering, tools, frameworks and the projects that I'll be working on. So if you are new to my channel and haven't subscribed yet, then please subscribe and press the bell icon to stay tuned. So today's video is about this framework called as test containers that developers can use to write effective integration tests. As a developer, while writing code, we are expected to write at least two levels of test cases, and those are unit tests and the integration tests. In unit testing, we cover code flow for a simple piece of a software application. It could be as simple as a function or a class. And if function is composed of another method or using class that forms a different building block, then we end up mocking its behavior using frameworks such as Mockito in Java. When it comes to integration testing, we write tests that checks the glue that connects different components of your software. In integration testing, we test how one component interacts with other components. So in integration testing, we mostly try to avoid as much as mocking that's possible. Let's try to understand how we write unit tests and integration tests with an example of a REST API. In this diagram, we have an API that takes temperature value from a sensor and saves it to the database. The code for this API is broken down into what's popularly known as three-tier software architecture. At top level, we have temperature controller, which defines structure of a REST API. Then at business level, we have a temperature service that has validations and other core logic that calls data layer. And then finally, we have sensor repository at data layer, which deals with saving or fetching data objects from database. When we write unit tests, we write them only for the method that belongs to a particular class and do not consider behavior of external methods that are called. In this example, temperature controller tests contain only tests for methods that belong to temperature controller class. The method calls from temperature service are simply mocked with dummy behavior while writing these test cases for temperature controller. Same applies to the tests written for temperature service. Here we mock behavior of sensor repository method calls. But when we write integration tests, we should be testing the code flow right from the representation layer to the data layer. The problem, however, is that we don't usually consider data layer in integration testing and end up mocking the method calls which actually saves or fetches data from database. Now this is done simply because we do not want to maintain another environment for database just for integration tests. Most of the times the integration tests are run whenever the code is built in CI/CD pipelines, and this happens quite often while a feature is being developed. Let's assume we maintain separate environment for database just for executing these integration tests. Over the time, the data state will keep on changing as the test cases are being executed again and again. And it may happen that test cases start failing suddenly simply because the data is not in desired state. This often leads to overhead of cleaning data time and again so that all the tests are green. Problem with mocking data layer is that important data constraints that are part of database schema are missed from integration tests and unit tests, which may lead to improper error handling and lead to data exceptions which are quite common in production environment. Now all of these problems can be solved using test containers. Test containers allows you to spawn Docker containers whenever you start executing the test cases. The lifecycle of a container is tethered to that of a test case. So if your CI/CD pipeline runs on a node that has Docker runtime, then you can easily spawn container of a database and initialize your database to some desired state and execute your test cases against it. And all this happens in a code where tests are written. In this way, the data layer can be tested and we only spawn databases when the test cases start running. Once test cases are executed, then the database container is destroyed. Thus, we solve all the problems that we mentioned previously. Currently, test container is available for all the popular languages such as Go, Java, Python, Rust, .NET. Test container is compatible with JUnit 4 and 5 in Java. There are a couple of modules provided for some of the databases, queues, and load balancers. However, in this video, I'll be showing you that how any Docker image can be used in integration tests. So I'll be using an example of a sensor API that we already discussed. The code is available in the GitHub repo and I'll attach the link in the description. So in this demo, I'll show you how test container is used to start MongoDB container whenever the integration tests are run. So here is the Spring Boot project in which I created two APIs, one to record the temperature from a sensor and the other API to get the average of temperatures recorded by a particular sensor. And basically I wrote test cases or the integration test cases for these two APIs. In this class, there are integration tests for these two APIs which are executed in order. And all I had to do to start a MongoDB container was just to write this annotation and uh, declare this instance of a MongoDB container. Now let's understand how MongoDB container class is implemented. For any container that you want to use, you can define a class like this, which extends from a generic container. And in a constructor, you can pass a name of the Docker image from which you want to create a Docker container. You can also define certain things like you want to which port of the Docker container you want to expose to your local environment using with expose methods. You can also mount certain files and folders onto a Docker container using class paths resource mapping function. You can also set some environment variables from on a Docker container. So once Docker container is started, it will go into the execution block of a start method. In the start method, you can set certain application properties based on the container properties. MongoDB basically starts on the 27017 port, and we had exposed that port. Now Testcontainer starts this Docker container on the random port of your host system, and that port number you can assign to your Spring application property. So your Spring application can use this port to communicate with the database. Now let's execute these test cases and see that MongoDB container will be created when the test starts executing, and when the test execution finishes, the container is stopped. Now you can see that tests are starting, and here you can see that a container is started on 27017 port, which is MongoDB's default port, and that was mapped to some random port. And once the text execution gets successful, the containers are automatically killed. So this is how I use test containers to write integration tests in Spring Boot. Let me know what are your thoughts and suggestions in the comment section. I hope you liked the video and found it informative. If you did, then please like, share and subscribe.